We are at Advanced Trade Fairs with Mr. Joaquin from Staubli. Nice to meet you, sir.
Nice to meet you, Alex.
Could you tell us a little bit about Staubli and maybe about the history?
Yeah, we are a Swiss company. We have 150 years working in the industry. We started in textile, then we the group grew up, working also in the electric companies and also in fluids, and then we started also with robotics. We are a company working in the industry.
So we moved from textile to connectors and robotics.
Yeah.
This is a large portfolio.
Yeah.
Maybe we can talk a little bit about the connectors.
Yeah, I'm working in the electric part. We have some products here. Will be the Combitar. That is a modular connector that we can combine every signal from power, fluid, coaxial, RJ45.
So I see that this is a modular connector.
Yeah, it's modular connector.
So I can change between the connectors then.
Yeah.
So this one is for current?
This is for fluids.
Ah, this is for fluid.
Yeah.
Okay. And signal, I understand?
Yes, signals, that is high voltage.
Mm-hmm.
This is power. We can get till 300 amperes and 15 bars in hydraulic. Totally configurable. So there's no two equal connectors.
Oh, this one that you can open and build by yourself?
Yeah, this is easier way to work with it. We can change the different part of it. Just adding, working.
Are they compatible?
Yeah, of course.
Oh. Okay.
Same as these ones. So we have the rack connection and also the air connection. Yeah, and also we work with high powers. This can handle till 1000 amperes and 1000 volts. So it's for very big transmission of energy. We also produce cable, flexible cable.
Oh, all right.
So it's quite flexible, as you can see. Yeah, it's silicone, and also the copper has very thin filaments. So that two properties makes the cable quite flexible.
Could you tell us, for example, where can we see this product?
For example, in mobility, we're working also with machines that generate electricity. Marine industry is an example of our connector, a Combitar, that you can see as it can connect signals, and then the fan will move.
And the light will turn on. And then it disconnects.
And then we'll connect the power for the screen. Also that connector has 100,000 cycles of connections. You can do all that connections in just one cable. Don't need to connect and disconnect different connectors, just with one.
Oh, we are going to see the fluid right now.
Yeah, exactly. Quite interesting to mix fluids and electricity. We have here an example of just models of fluids, different ones. We have seen 3 millimeters of pass, and then we have also that one that is just power signals and high voltage. And then we have data with RJ45, coaxials.
So we are here in the advanced factories, and it's all about Industry 4.0. Is there anything that you would like to add from Staubli, that how Staubli is contributing for Industry 4.0?
Yeah, we are working in every industry, every market, automotion, e-mobility, pharma, every industry we can get something from that.
All right.
We can offer something.
Okay. Thank you, Joaquin. It was a wonderful interview.
Alex.
Thank you. We are with Mr. Mark. Nice to meet you, sir. Can you explain us a little bit about what we can see, what robots and their applications, and what you have on the stage?
Yeah, sure. Thank you for your visit. What we are trying to show here is a little bit to get some ideas about what we can find in a factory, in this case e-bike or electronic bike manufacturing. So we see different steps of this process of manufacturing. If we go here, and let's have a look to the first show, we will find what we are showing here is a big robot for machining. So we are trying to showing here, in this case, a fiber laser cutting for all the chassis of the e-bikes. We have also these special robots, in this case a TX2 160L HDP, that means high dynamic precision robot. So it's something similar to be very accurate when you do this kind of laser cutting.
Why laser cutting? Because of the precision? right?
Yeah,
so
yeah,
this
yeah.
is a laser cutter mounted on the robot.
Yeah, just in this case we choose this technology. It depends about with kind of machining, what do you want to do, but in this case it's a non-contact machining process. So for robotics it's something that is very easy because if you are using, for example, electronic mill, there is contact. So, if you are working with heavy metal, it's going to be harder and the process is going to be slower. In this case, there is no contact. So we want flexibility, and with a laser, we can you do this kind of cuttings with complex geometric parts, also big parts, with any problems and in a very fast way. So it's quite nice and quite interesting for the industry to optimize the processes.
And at the bottom, we can see the connections and the rig that controls the whole robot.
Yeah.
Those are the connectors that we were talking previously with Mr. Joaquin.
Probably. Sure. Yeah, we also, this is our controller. This is the brain of the robot. We have 3 different departments. The first one is the power supply, so we can choose between monophasic and triphasic depending the size of the robots. Then you have the one on top, which is where the drivers are, and the one in the middle, the narrow one. This is the authentic brain. There is a CPU inside. There is the input and output digital to control mostly everything. And yeah, of course, we are using also these connectors from our connector division. Sure. Here, what we can see is the assembling of the engine that our electronic bikes is going to use. What we are trying to show it is putting all together different technologies. Here you can see 2 mechanics, the 2 different mechanics of robots. We have a 6-axis robotics and also 4-axis robots. Sometimes if we are going to, if we don't need extra degrees of freedom, we can, and we are going to work also in the same flow but in different levels. For robot axis, it's a good solution because it's an easy solution, it's a cheaper solution, the speed is higher, and also I think it's very robust. Less mechanic, less problems, so it's also
less moving
good.
parts, better.
We are trying also to choose the better mechanics for the applications that we want to do, so it's also good to have different options. And also here we have the combination of the 2 robots. In the middle we have a tool changer. So if we talk about robots, we are talking about flexibility in production. So if you want to add more flexibility, we can work with different tools. If we have a tool changer, we can do different applications, but everything is inside the same space. So you optimize the volume. So that's quite interesting. And also we have XDS from Bekov. Bekov is another automation brand technology. And in this case, we are trying to show how also we can fit parts in a flexible way, because robots are flexible, but now we need also this kind of fitting parts also to be as flexible as the robot is. So we think this is a good solution. It's not ours, but we want to show it because I think everything put it together is quite interesting.
About the color, it has to be yellow?
No, it's not mandatory. Yellow is our standard. It's RAL 1028. Which is the same RAL that used the famous company Caterpillar. It's the Caterpillar yellow, so that means powerful robots. But it's just our standard. Over there we have a white robot. You see again, it's a white robot. In this case, we are trying to show a robot that is performant for the pharma industry. Pharma industry is an industry where we work a lot because our hygienic design. You see that the Staubli robots are famous because you don't see engines, you don't see electric wires, everything is encapsulated inside the arm. That brings us the possibility to work in clean environments, in aseptic environments, and what we are trying to show here. You see that in this robot the connection is under the base, so it's completely hidden.
Yes.
So it's very smooth, it's easy to clean, and in some cases we can work in aseptic environment. So that it means that we can clean it with peroxide. And
right.
Here, something that we are trying to show is the robot and human interaction. We don't have a specific cobot, but we have industrial cobot that works in a safety way when we have to interact with person. Here you see that the cell is open, so we can go inside, but we put some light barriers. So if we go inside, I can modify the way how the robot is going to
react.
React.
Can I try it?
Yeah, sure. Go ahead. Yeah. In this case, what we decide is that when we go inside the cell is going to stop. Yeah, sure.
Okay.
Yeah, everyone likes to play with a robot. You can define, in this case we are going to stop the robot with power inside the arm. We keep the power, so it's easy for the operator because everything is not stopping. In the past, if you work with industrial robot, it's mandatory that if you open the door, for the regulation everything falls, you have to call maintenance, we have to restart the robot again. Here we can work in a most easy way with the robots, and also we can define, okay, we want to stop with power inside, we want to slow the speed, we want to create, I don't know, invisible Cartesian volumes that we can activate or deactivate depending the interaction of the people. Even we can put a sensitive skin. We don't have it in the both today, but if you touch it, it's going to stop in a safety way. So if you see our factory, we are the only robot manufacturing that is manufacturing the robots in Europe. So that means cost for manufacturing, because in French, the automation is a must if you want to be competitive, no? So of course there are some parts of the manufacturing of the robots that are automated, not the robot itself, but the parts of them, yeah. But at the end of the line, there is a lot of people who are assembling all the parts together, we are painting the robots, and we are testing the robots for several hours to be sure that everything works in a proper way.
Even if there are robots, we are still cooperating together.
Yeah.
Yes.
Yeah,
Thank you, Mark. Thank you for the interview.
You're
Thank
welcome.
you for your time. It's wonderful. Thank you.
Thank you very much for your visit.